Then it's code in the data, give the keyboard a punch, then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean, and it's, oh boys, can't you code it? Program it right. Nothing ever happens in the...
Welcome back to my Stata video series. This series of videos is mostly to support my class at the University of Maryland, SOCY 699C, which is a class on statistical programming using Stata. But I welcome all others who enjoy these videos to use them if they're helpful. So we're going to push on today with the information where we left off last time about creating new variables, and now I want to talk about how to clean up your data set. Specifically, we're going to talk about how to store your data efficiently, how to add different kinds of notes to your data set to help you manage your data workflow, and different ways of viewing your particular data. The first thing I'm going to do is create a couple of new variables. We went through these in the last video. These are two dummy variables for race, one for black versus white and one for non-white versus white, and they're coded 0 and 1 for each of those. So we'll just create these variables and look at the tabulations of them, and nice little 0, 1 variables for us. Now, these variables are not stored as efficiently as they could be. And by efficiently, I mean Stata stores its variables in a default format that uses a fair amount of disk storage and a fair amount of memory in the computer. If you start using large data sets, you may eventually run out of space in the memory of your computer to store the data. Stata is a lot like a spreadsheet in that when it reads a data set, the entire data set has to reside in memory of the computer. So managing your data for efficiency is a good thing. These two variables are not saved in a very good format. Let's go ahead and take a look at them using the describe command. You can see that these are stored as floating point measures under the storage type. What I'm going to do is use a generic command called compress. There's no options that I'm going to use. It's the simplest command in Stata that will go through all of the variables in my data set. We'll look for the variables that can be stored more efficiently, and if they can be stored more efficiently, we'll create that particular variable saving space. So down here and issue the compress command. Stata went through my data set, found those two variables, and discovered that they could be converted from floating point to byte storage. Let's go ahead and issue that describe command again and see what that looks like. And you can see where they were floating point, they're now bytes. So far, this has only saved memory in my computer, the RAM memory. If I don't save my data set now, then obviously the changes from floating point storage to byte storage won't be saved, and I'll have the same storage issues later. So this is the point where I'd probably save this data set so it's stored efficiently on my hard drive, so the next time I read it, I have the most compressed variables possible. You can issue this command anytime. It normally doesn't take very long to run, although I will tell you when I get the General Social Survey, when I download every 2 years the new version of the General Social Survey, they don't compress the data set typically, and it takes a little bit to run because there's 5,500 variables. It has to do a lot of work. The reason it ran so quickly just now is that I've already compressed this data set, and it was only 2 variables that had to be dealt with. So you need to kind of pick and choose your battle. Run this thing once at the beginning when you get a new data file. Make certain everything is stored efficiently, and then maybe every time you create new variables, when you're done creating the variables before you save the data set, I usually put a little section called cleaning up the data, and I just compress it to make certain it's stored as efficiently as possible. Let's push on. Stata lets you assign notes. Now, notes can be assigned in 2 ways. You can write a note and attach it to the data set, or you can write a note and attach it to a particular variable. So up here, I'm going to create a couple of notes that will be attached to the data set, not to a variable. My first note says, remember to check race, sex, recodes. So In another video, we created a new variable which was the intersection of the race and sex variable in the general social survey. Maybe I was running late and had to get to class, and so I never had time to fully check that variable. So I can write myself a note, so the next time I come back to Stata, I can check my notes and say, oh, this is I wanted to make certain that I checked that variable and verify that it's doing what I want it to do. So I'm going to go ahead and just issue this command. So it's just note with a colon, and then my note follows. Now when I type in notes, it displays any and all of the notes in my data set. I'll add 2 more notes. In these 2 notes I'm adding, you'll see the letters TS, capital T, capital S. That's when Stata finds the letter capital T and capital S surrounded by spaces. In the note command, it will automatically add a date and time stamp. So this is a nice feature if I want to date stamp, time stamp my notes. Now you'll notice that these 2 notes, notes 2 and 3, are identical except for the placement of the timestamp. The first one places the timestamp at the front, and the second one places the timestamp at the end. Upon looking at this, I can decide that I don't like that first date stamp. I really only want notes 1 and 3 in my data set, and so I can use the notes command with drop. And the big issue here is that I have to specify that that I'm using my underscore DTA, which means my data file. So when I execute this command, that second note will disappear and I'll be left with 2 notes. Now this left a gap. My notes now are numbered from 1 to 3 because I've dropped note number 2. I only want these 2 notes, and I'd rather have them 1 and 2, not 1 and 3, so I need a way to renumber them. If I don't renumber it, and I were to add another note right now, it would be listed as note number 4. There still wouldn't be a note number 2. So I can renumber the notes underscore DTA in my DTA file and list out those notes. Now the next note I create will be note number 3. So that's how we can create notes attached to the general data file. We can also do notes attached to specific variables. For example, here I'm generating a new logged variable of the variable age, and I'm going to attach 2 notes to that. Now when I type in notes, I get the notes if I just type in notes alone, I get the notes for the data set and the notes attached to that particular variable. I can control what notes to look through. Well, we just saw if I just issue the notes command, I get both data file and variable. If I issue the notes command with underscore DTA, I get only the notes from the data file. And if I issue the command notes with the name of my variables I'm interested in, I only get the notes attached to those particular variables. Great feature. I encourage you to use this. Use notes copiously. Label your data set. Make things easy for yourself, particularly if you have a data set you're going to be working on intensively for a year or more, like for a dissertation, or you get your first tenure track position. You really need to be able to keep track of all these issues. Now, Notes has another nice feature in it that you can search through your notes for a particular word or phrase. For example, in the data set, in the notes that we've just created, I can search for the word base. Maybe I just remember that I had something about base 10. If I search for base, I should find it. I could also search for dummy, as in dummy variable, and you'll notice that dummy was not found. That's because this search command respects case, and when I made my label, I used a capital D for dummy, and if I reissue that search command, it shows my dummy variable notes. In the spirit of cleaning up my data set, I might decide that some of the variable names I have available to me, I don't like them. For example, we created a variable called LOGAGE, the natural log of the respondent's age. And maybe I prefer to acknowledge that it's really the natural log, and I want to rename that variable ln_age for natural log age. The rename command simply is rename old var name, new var name. And now my variable is the name I prefer it to be. I can also change the order of variables in a data set. For example, I can order this variable I've renamed log name wage, log ln age, and put it after the year variable. Look over at the variables window over here, and you can see that year is the first variable, and that way down at the bottom, the last variable I created is this ln age, and my command here will move it after year. I can also move groups of variables. So now I'm going to use the order command to move log natural age, ln age, and log 10 age, the same logarithm transform variable but using base 10. And this time I'm going to put both of those variables, instead of after a variable, I'll put them both before the variable prestige. So over here in my variables window, you can see that prestige is right here. And when I issue this command, it should put them just before that variable, which it does. Further cleaning this up, I should probably add variable labels, but we're going to skip that for now. I can subset my data set. So the General Social Survey is very large. It takes up a lot of disk space, a lot of RAM, and it's difficult to move around. And I've got too many variables in it. So one thing I can do is to save space and to make the data set easier to use is I can keep or drop variables, and I can keep or drop observations. My first command to make a subset of data is going to be the keep command. Keep and drop work the same way, but keep keeps the list of variables that comes after it, where drop drops them. Obviously, you use keep, whether you use keep or drop depends on which is the shorter list of variables. So I'm going to create a new data set, and I'm going to keep year and all the confidence variables, sex, and age. Then I'm going to use the drop command with an if modifier. I'm going to drop cases if year is equal to 1972 or year is equal to 1986. That vertical bar is the or connector, and the and sign would be how you would do if it's missing and, but obviously you can't be missing in 1 year and another. You can only be missing in 1 year or another. Why did I pick those 2 years? Because when I looked at the data file and I did a tabulation of these confidence variables, they were not asked in those 2 years. So I may as well drop all those cases which are still in my data set. There's my keep command. It tells me how many observations were deleted. And then finally, I'll describe again, and you can see that I have far fewer variables, far fewer cases, and my data set size is smaller. Again, if I don't save the data set, when I come back, I'll only have the large data set to work with. This would be an opportune time to save the data set, and so when I come back, I don't have to do all this work again. I can make this even a smaller data set and more useful. I know that when I do a lot of the things I do in my research, that I only operate on cases that have valid values for all of the variables. So I can issue a keep command, and I can combine this with a function called missing. And then I can use the negation symbol. So let's go ahead and look at this line of code on line 200. Keep if exclamation mark missing. Exclamation mark means not. So keep if not missing, and then I have the list of the variables in my data set that I'm interested in. I didn't put year in that list. I could have, but I know year is never missing. Every respondent has a year they did this General Social Survey. This should take any cases within a year that are missing on any of these variables and drop it from the data set. And again, we can describe this new data set and see that we've now cut our data set size even more and our number of cases even more. I have no missing data for any of these variables in any year. And I can prove this by using the tab stack command. So I'm going to calculate statistics for all of these variables. The statistic I'm going to calculate is the sample size, and I'm going to do this by year. And you'll see that every year will have valid data, and every variable within a year will have exactly the same number of cases as I expect. Looking at 1972 and reading across, same number of cases for every variable. These are all the non-missing cases for all of these variables. Looking at 2012, same thing. Just every year, same number of cases. If I save the data set now, again, I have a nice compact data set. I could store it in the cloud easily, put it on a flash drive. It's just a lot less bulky to work with than that very large cumulative general social survey data set, and it keeps me focused on the variables of interest to me and the cases of interest to me. The last thing I want to show you is the edit and browse commands. Truthfully, the edit command, I wish I hadn't learned it. And I probably shouldn't show it to you, but I'm going to show it to you anyways. The edit command opens up a spreadsheet-like window that shows your data in Stata. The difference between edit and browse will open up the same type of window, is that in edit you could change the values of your data. If I just type edit with no options and no variable list, it opens up this window. Now you'll notice that some of the variables have different colors. Blue means that this is a numerical value with a label attached to it. So if I come over here, we see male is coded 1, and moving down a cell, female is coded 2. We can come over to this column, see white is coded 1, and coming down a couple of rows to black, black is coded 2. And so forth and so on for all the confidence intervals. Notice that the year variable is black. Black means that it's displaying a number, and that that's actually the number. There is no there's no value label attached to it. Now, if I come into this data set and I change something, so here I have a black respondent who's coded 2, and I just type in the number 1, and I hit enter. I've taken that person and changed their value, and it changed the value label, and I have no record that I've done this. When I escape the edit window, close the edit window, you'll see this is the command that was issued, and it's a replace command, so we're already pretty comfortable with that. It says replace race equals 1 in 16 for observation 16. Other than that, there is no record that I've made a change to the data set, and no way that I could ever figure this out again down the road a couple of weeks or a couple of years that I made this change. If you're going to make this kind of change, don't make it in the editing window. Put it into a do file, document it, and make it part of your workflow so that you can see exactly what you've done and track any errors in the future. My suggestion is to use the browse command. The browse command will give you the same view of the data, but it won't let you change it. Now, one of the nice things that I've discovered in using Stata 13 is that I can make certain variables disappear out of the browse window simply by unchecking them. And so I've found that this is a quick way to kind of subset some of my data. The data still exists, it's just what's being shown to me. Another great feature of browse and edit is that you can subset the data from the command line. For example, here's the browse command for a limited number of variables. Once I'm in browse, if I want to look at some of the others, confidence and labor, I can click on it there if I like, but it sort of gets me into the ballpark with the variables I'm interested in. I can also issue the browse command with the no label option, and that's a great feature if you want to see the underlying values. Again, look at the color of the values. There's no blue values anymore. Value labels are shown in blue, values are shown in black. I can subset on multiple kinds of features. I can use the if modifier to look at a limited set of variables, year, age, sex, race, and confidence in business, only for year 2012. I can combine this with year equals 2012 and sex equals 1 and race equals 2. We know that sex equals 1 is for men, for males, and race equals 2 is for black. So now I'm going to look at a limited subset of data. And you have to think hard about what the subset actually is. First of all, it's only those respondents who responded to every question in my data set, whether I'm displaying them all or not. Number 2, it's only the people in 2012. Number 3, it's only people who are black. And number 4, it's only respondents who are men. And if I move down, you can see that I really don't have, once I limit my data set this way, I don't have that many cases. There are not that many black men in 2012 who answered all of the confidence questions and the race question and the sex question and so forth. Last thing I'll show you, and this is kind of hidden away in the Stata documentation. I don't use it very much, but you might find it useful. To be able to use the if statement, you have to know the underlying value. You have to know that 1 is equal to male and 2 is equal to female, and that 1, 2, and 3 are white, black, and other respectively for race. There's a way you can type in the value label if you happen to know it and specify the value label that it's attached to. So down here, I'm going to browse the variables year, age, sex, and so forth. If year equals 2012 and sex equals female, and then notice there's a colon here, followed by the name of the value label attached to the variable I'm interested in, sex. And race equals, and in the quotes, white, and that's white based on the value label called race. How do you figure out what these value labels are? You have to use the label command to look at them. And you can get these by using describe. I hope this video was helpful to you. We've done enough work now that you should be able to complete the homework assignment that I've assigned and start turning it in, and we can go back and forth on it until we get that thing up to speed, and then you can move on to the next module in our Stata course. As usual, if you have any questions, give me a call or send me an email, and I'll do my best to answer them.
And it's code in the day to give the keyboard a punch, then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? Program it right. Nothing ever happened.